We were so fortunate to have the team from FOHSE come and visit our facility to discuss how we're implementing their lighting systems. As a leader in lighting innovation, FOHSE continues to push the envelope with cutting-edge technology, optimized light recipes, and full spectrum control. Endless was proud to be the first cultivation facility in the world to use the FOHSE A3i Pros, and the results have been undeniable. In this panel, we sat down with Martin Boerema from FOHSE to discuss our partnership, the evolution of lighting and cultivation, and the impact it's having on the industry. Enjoy.
My name is Martin Boerema, and I'm the Director of Horticulture Services, and I help with grower support and also recipe development and cultivation in general.
So my name is Gary Holland. I'm one of the founders of Endless, and I've been Chief Operating Officer, Director of Cultivation, and now I'm heading up our robotics division and R&D division to get that up to speed. And we perfected the grow methodology here. We've used the FOHSE lights to truly enhance our production and so on. Well, I'd say a lot of it has to do with our analysis of a variety of different lights. And we found that FOHSE allowed us to do some things with other lights. One is the ability to push a lot of energy through the canopy, and the other is the spectral changes at which they allow. And what that allowed us to do as more of a science-driven grow was to perform a variety of different aspects of grow methodology, apply different lighting spectrums at different times, different intensities. So that light was extremely versatile in our methodologies, which we tried to achieve. And that's what allowed us, and a great part to reach our 100 grams per square foot.
Yeah, we support your research by giving you the tools you can work with, and we also develop recipes, light recipes that then that we think will work better for your purposes. And so cannabis research is developing fast right now, so we have to stay up with the newest insights and research, and we adapt our recipes and a total cultivation approach as fast as the new technology advances. That's what we're trying to do. We can take on the spectrum part of it, the spectrum approach. We can research and base our newest developments on the latest research that's out there, and so we cannot stand still when it comes to developing new spectra, and so we are constantly adapting and improving, and we can only make it work in collaboration with a company like you. Okay, so the proof is in the pudding, right? And so we will be doing this, and we will have a pretty good idea that they will work, but then you make it work. And then that's where the collaboration is.
There was two things at which we primarily looked at in their spectral. And one is the ability to work within a tissue culture environment, and not like if you use like a traditional clone light, we found the spectral changes weren't enough, and we couldn't change the intensity and things that we needed in order for it to work for tissue culture to begin with. Because there's a variety of different ways in which you can use light under tissue culture depending on what type of plant you're doing. Now, we are primarily focusing on cannabis today, but later on we'll probably move into other areas as well. And the other aspect at which we're collaborating with FOHSE would be as we build the larger lab and warehouse concept, we're going to have specialized design lights and configurations in order to make that work. When you're looking at millions of explants and millions of clones, and those each require their own spectral, but they're all got to be stored in the same kind of warehouse. So we got to find a configuration that works, the lighting, the hardware aspect that works, the ability to turn it on and off a certain way, or all that, and then work within these spectral changes and so on. Endless is a scientific-driven grow, right? So we use biologists to analyze all the data. We use research equipment to analyze what's going on in the plant, and then we adapt our SOPs such as how we use lighting or feeding or whatever it is. And lighting is obviously critical to this plant. So you got three basic things: your lighting, your environment, and your feed, right? And then so lighting was critical, and FOHSE was critical to our choice of lighting because of their innovations and the light which they designed, the ability to use them a certain way, and the spectral changes that are within them. So when we started analyzing that and talking to FOHSE about how we were using the lights, they realized that, hey, these guys are not we're not just putting plants in the ground and trying to grow them well. Right? We actually are using scientific methods. We use biologists and through data analytics and so on to optimize the growth at all the various stages, optimize the spectral changes, the intensities, and all the things you need to do at different stages of that plant to optimize that growth. And so I think that when we started doing that and FOHSE started seeing what we were doing, that led to that component. And they go, well, these guys are actually doing something a little bit different.
The plants look vigorous, high production. One of the main goals of Endless was to create a configuration with good light penetration so that you get better results with the same amount of light. Okay, so it's not only light intensity, but it's also how it moves through the canopy itself. Okay, so I think you were successful in configuring the direction and create a diffuse type of light that has great penetration into the canopy, and it showed. Okay, so the bud size, top to bottom, was very uniform. We actually are designing light spectrum recipes for each stage of plant growth. Okay, so and a great way to do proof of concept is by sending it to Endless, and Endless cultivation can make sure or help us understand it works as it's supposed to. And I think that's a great collaboration there.
I think that there's two ways of looking at this. One is they're an innovative company trying to push the envelope in lighting, right? And then understand lighting application associated with whatever that crop concept is, right? And we're trying to perfect a high production, high quality yield concept that any grow can pick up and run with it, right? So that together works quite well. We're, like I said, we are pushing 100 grams per square foot. We have terps that are 2 to 3 times the average in the industry, and we've done that in part because of the FOHSE lighting and the ability to do these light recipes and tailor that light, both in the hardware configuration and in the intensity configuration.
Where there used to be one spectrum, one spectrum fits all approach, now there is a better understanding that each growing stage, starting with clones, with mother plants, clones, even 2 stages within the clone rooting, early veg, early flower, and later flower. All those stages, actually require a specialized spectrum approach, and I think that's where, in combination with understanding cultivation and the requirements of the plants themselves, that combination will bring us leapfrogs, I think, forward.
Well, there's a lot of things we measure throughout the growth cycle of the plant, right? So one is we're trying to understand the light recipe and associated with the time in grow, right? If it's the first couple weeks, second couple weeks, whatever that concept is, right? The other one obviously is the light intensity itself and ability of pushing that light intensity into the canopy itself. But we measure a variety of other aspects by using research equipment of the plant itself and how it actually responds. So by being able to measure the response of the plant to the current environments, we can optimize that concept. So that's part of what we're able to do. So using light recipes at different times within the growth cycle, and then measuring the response as we're doing, we can actually tweak that light recipe to optimize for that strain, that or cultivar, or whatever that type species of plant is, and so on. So,
yeah, new dynamic recipes for cloning, new dynamic recipes for flowering, improved spectra for veg stage. When it comes to fixtures itself, what I do is help design the cultivation side of it. That's where I come in. Yeah, the first half of flowering, the plants are still in a vegetative stage and they are transforming into flowering. It takes a specialized approach, and it's a delicate period, really. Okay? And also, you need to optimize the plant growth and plant mass, to ensure the best possible results as a flower. Once you're building your flower mass, that particular spectrum is not the best anymore. So now you have to kind of switch and get the best. It's not only compounds and turfs, but it's also bag appeal and morphology, right? So, and then the finishing itself is another stage. Okay, so there is a lot of room for improvement and for creative improvement, right?
Even with our current spectrum, we're able to tailor the different weeks within a flowering cycle, right? So for example, we use more of their heavy blue spectrum in the first 3 weeks because we're trying to reduce internodal spacing and we're trying to build sugar within the plant, right? So we're not trying to push the plant, and we're also allowing the plant to grow naturally at that stage with a higher sugar concentration, and we get a better rate of growth or cellular growth within the plant. So we see flower production much higher and the rate of growth of the size of the flower doubling in mass every other day and so on. We see that occur faster or much earlier than we would normally do under standard lights and so on. So those are some of the type of things that we do with that.
Growth is exponential, right?
Exactly.
So the better the start, the more gain at the end of the cycle.
Exactly.
That is the trick.
Exactly. Well, one is we just mentioned it, right? By using a variety of different spectrums, like the regular FOHSE A3Is have 3 spectral changes, like you got spring, summer, and then autumn, right? And we use those at different stages. And what that allowed us to do was optimize the growth characteristics of the plant at those different stages, right? So especially at the beginning, as we just discussed, because it's critical that you get sugar and internodal spacing down, because that gives you 2 things. One is a faster rate of growth, especially up front. And then the other aspect of that is when you're growing a flower, you want to grow that flower in a stacking methodology or a method. And what that does is you're better lighting around that flower, and you tend to have a better flower, a tighter flower, and eventually a bigger flower, right? Because you're focusing more of the light on the flower, not within the plant itself. So we use it in a variety of ways. And then like your autumn for spectrum, that's used for ripening the terpenes towards the end of so on. So these various spectral changes allow us to tailor and focus on different parts of the plant growth. If you understand the genetics of that particular cultivar and where that cultivar natively is from, for example, we have cultivars that are from Afghanistan or India or South America, that if you can mimic closer to the spectral changes of that particular region, then you might be able to say you get 1, 2, 3, or 4% better yield or quality out of that plant. Well, it doesn't seem like much, but when you start looking at hundreds of pounds or thousands of pounds, 1%, of 1,000 pounds, that's 10 pounds, right? So, and so on and so on. So it makes a big difference to people's bottom line. But more so, what we want is a better quality plant, right? So we can mimic the closer to that genetic genome, then we can actually push that plant and grow a better plant. Not just better yield, but better quality. And so what we're going to be doing is measuring the spectral changes of different regions and throughout the day, for example, because we know there's slight spectral changes, for example, as the sun's rising throughout the day. Not much that we can't say the difference, but we know that the plants can detect that difference, right? And so it's also depending on the factors of where you're at within the world, the conditions and environment within that different parts of the world, if it's drier versus humid. So you get scattering of light, like blue lights and green lights. That's why we have a blue sky, right? And so that changes in the environment will affect the scattering of light. So you'll get spectral changes at the earth itself, where that plant may be. So we're looking at that, and then we're looking at things such as the heating changes, temperature changes within the day, and the natural characteristics of the plants to try to protect itself from high heat during the afternoons and things. So we look at all these different things, and by doing so, we do 2 things. One is we optimize the growth of the plant, and we minimize the stresses on the plant. So if you took a strain that's naturally given to Afghanistan, you try to grow it under a condition that we'd see in North America versus something to places warmer, you could stress that plant throughout its entire growth. In essence, you're stunning the growth of the plant. It never reaches its maximum potential. So that's the type of things that we look at, and the FOHSE lights allows us to do those things.
Each bud requires a certain amount of light, DLI, to develop to its full potential. So if you have too many buds and not enough light, you're diluting the available light for each body, and they don't come, they grow small, right? So that's why you tailor the amount of growing points to the amount of light that reaches the plant.
Exactly. Yeah, so one of the things we do in that matter is we minimize actually the number of bud sites by allowing more hormones to develop in that primary close. We see a bigger cola, and we also see a more potent, in other words, better terps and so on, cannabinoid production in the end. So there's a variety of ways of doing it, but light is the key, right? That's the light is what ripens those terps and so on, allows them to grow. I would say one of the main concepts, well, two, spectral changes, right? And the second is the ability to even the light distribution across the room. So one of the things we found in the A3i was you're able to turn the bars out quite a bit. I don't know what the full amount is. It's probably somewhere at 45 or 50 degrees, right? So one of the things that we found is we didn't want hot spots over the plant. So how can you even the distribution of energy across the room where it doesn't matter where table? Because one of the things we found in older lights was the newer or stationary bar lights, when you have to put them over your canopy, you typically lose about 10 or 15% of the lighting around the edges. So you got a hot spot in the middle, and you got a cooler spots out here. And there's nothing you can do to change that, right? The only place that gets changed is when you have light after light, so you get a little bit crosstalk there, right? But with the FOHSE A3i, we can change the bars. We actually move them out about 30 degrees, so you get better lateral penetration. But what we also found is no matter where we measured the light spectrum in the room, the energy of that light spectrum, the micromoles, the ppfd, we got an even distribution of light. And that was critical to minimizing hotspots and getting even growth across our canopy.
The quality and uniformity of the clones themselves, and not only that, the quality of the mother plants.
Exactly.
Has a great impact on uniformity at the end of the cycle.
Exactly, exactly. So first of all, we are going to continue the horticulture side of developing and understanding how to optimize plant growth, both on spectral changes, intensity changes, and procedural changes, like our methodology of feeding and so on, right? But on the other side of that gets back into the tissue culture side. And on the tissue culture side, we look at not just traditional tissue culture, where we're going into bioreactors and things that are kind of a newer technology, moving away from the older technology, but we're also going to be looking at genome concepts such as CRISPR technology, DNA barcoding, and things like this, where we can look at the overall genetics and optimize the growth of that plant and optimize it for the growth at which conditions at which we want to apply it. So there's a lot of things at which we're moving into from that perspective.